This video will cover probabilities, z-scores, and the areas under a bell-shaped curve. Remember, a bell curve is based on the normal distribution. And in the examples 1, 2, and 3 that we'll look at, the mean is going to be 50, and the standard deviation is going to be 10. As a reminder, a z-score is found with the formula x minus mu, or the mean, divided by sigma, the standard deviation. Let's begin with number 1. We're going to focus on a less than problem, and we're looking at the area to the left because it's less than. So we want to know the probability of having a data value less than 30 when our data values in our population have a mean of 50 and a standard deviation of 10. Okay, first we need to find the z-score. And the z-score is found by taking 30 minus 50, dividing it by 10. And this equals negative 20 over 10, which is negative 2. So we know our mean is in the middle, which is where 50 was, and the z-score is negative 2 for a data value of 30. That means that the value of 30 is 2 standard deviations to the left of the mean, because that was a z-score of negative 2. So it's 2 standard deviations to the left of the mean. We want to know the probability that all of the data values that are less than 30. So we want to know the probability, or the area under the curve, that is to the left of 30, or to the left of a z-score of negative 2. So I am now looking at the probability of z being less than negative 2. In your homework, there's going to be a table, which we find over on the right. This is a list of the areas to the left of a particular z-score. Our z-score was negative 2, so we want to notice that the area is 0.0228. The area to the left of that z-score, which is 0.0228, is the probability of having a z-score less than negative 2. Now we can connect that back, and we can say that the probability of having a data value less than 30 is equal to 0.0228. Now I'm going to look at having a probability of having a data value greater than 45. So first thing I need to do is convert this 45 into a z-score. My data value is 45, my mean is 50, and my standard deviation is 10. This becomes a negative 0.5. So the z-score is a negative 0.5. That tells me that my data value of 45 is still to the left of the mean, but it's only half a standard deviation to the left of the mean. So I'm going to draw a vertical bar here between where the mean is at and where 1 standard deviation is at. Okay, this problem had said, what's the probability of being greater than 45? So we're looking for the area to the right. This 45 as a data value had a z-score of negative 0.5. So I'm going to find the probability of having a z-score that is greater than negative 0.5. This time when I look at the table on the right, I still look for that negative 0.5 as a z-score. But this probability of 0.3085 is actually the area to the left. All of these tables that have z-scores and areas provide the area to the left of the particular z-score. The area under a bell curve all sums to 1. That tells me that I can find the area to the right of the curve with 1 minus the area that's to the left of the curve. A general rule is that if you have a greater than statement, you can find the probability or the area to the right of your particular value of interest by taking 1 minus the area to the left. This equals 0.6915. The probability of having a data value greater than 45 is 0.6915. We are finding the probability of 30 being less than x, which is less than 45. What this means is we want to know the chance of having a data value that is between 30 and 45. We remember from problem number 1 that 30 was 2 standard deviations below the mean. And we remember that 45 was half a standard deviation below the mean. If problem 3 had not built on problems 1 and 2, then we would need to find the z-score for 30, and we would have found that with the formula 30 minus 50 over 10. Right? So that z-score had been -2. And the z-score for 45 would have been found also with the z-score formula, and we would have had a z-score of -0.5. If I draw this on the bell curve, what I'm trying to do is find the area between those data values. Earlier, we had found that the blue area was to the left of the curve, and that blue area was 0.0228. And likewise, earlier we had found that the green area, which was from 45 all the way to the left, which includes that blue area, was 0.3085. So if I want just the red area, then I want to take out this blue area from the greenish area that we had before. I want to remind you, up in problem 2, this had x is greater than 45, and here we're dealing with x is less than 45. So we're interested in the area to the left of that green line where 45 was at. We're not interested in the area to the right. Okay, so now that I have those two values, those two areas, I need to subtract 0.0228 from 0.3085. This equals 0.2857. That tells me the probability of having a data value between 30 and 45 is 0.2857. Problem 4. Use the Wechsler Adult Intelligence Scale with mean IQ 100 and standard deviation 15. What percent of the population has an IQ below 118.75? We know that the mean is 100, and I'm looking at 118.75, which is above the mean. So that means that the 118.75 will be up here in a positive 1 or 2 standard deviations. Let's find the exact amount. The probability for having an intelligence below 118.75. First, I need to find the z-score. This is 1.25. So I know an IQ of 118.75 is 1.25 standard deviations above the mean. And I want to know the percent of the population that has an IQ below this particular data value. Means I want the area to the left. Looking over at the chart on the right, I see that I have a z-score of 1.25, and that has a area or probability associated with it of 0.8944. So the probability of a data value or an IQ being less than 118.75 is 0.8944. That means about 89% of the population in the world has IQs lower than 118.75. Part B. What percent of the adult population has an IQ over 70? I need to find the z-score for a data value of 70. That equals -2. An IQ of 70 is 2 standard deviations below the mean. The question, though, is what percent of the adult population has an IQ over 70? I'm looking for the area to the right of 70. First, I'm going to need to find the area to the left of that 70. Remember, 70 is associated with a z-score of -2. So on my table, I'm going to come over to -2, find the area to the left of -2 is 0.0228. And I want the area to the right. So I want to go 1 minus 0.0228 and find out that the chance of an adult person having an IQ score over 70 is 1 minus 0.0228, which is 0.9772. That means about 98% of the adult population has an IQ over 70.